So I'd like to introduce you to my progress on the inductive wireless power transfer kit for high school students. This is the original prototype done on the ubiquitous Electronics Learning Lab. Awesome, from Radio Shack, totally awesome. This is the original circuit that goes to a primary coil with the capacitor right there. So this is the driver's circuit for the primary. Real quick, you've got a 555, a 5-volt voltage regulator, so it doesn't fry the 555, and you've got your NT2390 power MOSFET. It's a high-speed switching MOSFET. You can use pretty much anything you want, just as long as it can handle the voltage. Those are both heat sink because they get pretty hot. Voltage out of here is around 10 volts. That goes to the primary oscillating, and so you get pretty good transfer with this. So that's the original prototype. I made a second one in a kit box here, and you can see kind of the same setup. You've got the 555 timer here with the two trim pots. You've got a status LED right here that's going to get wired into, it's going to get placed on the side of the box at the bottom. You've got your 5-volt voltage regulator, heat sink with a cooling fan on that power MOSFET to keep things very cool as possible. And then that's a 12-volt voltage regulator, so a 7812, so that you don't burn the fan out. Again, I've optimized it to be passing around 10 volts directly into the primary. That umbilical right there is the primary umbilical. Goes into, sorry, there's a socket right there. That green thing right there is the 104 capacitor. So you've got a 22 turn primary right there, and when you turn it on, it sends energy over to this secondary coil with a bridge rectifier and a 5-volt voltage regulator so that I don't burn out the LED. I'm getting a lot more than 5 volts over here right now, so you'll see. So we'll pass transfer power easily within 6-7 centimeters, keep the LED lit, and then we'll move it in. So we'll take a look at the waveform once I turn this on. It's kind of hard with one hand, so let me get that. I think I got it, and hopefully we'll have some. There we go. Okay. So you can see the fans going. Got me status lights on. Everything's going good so far. And sure enough, you have the LED is lit. And sure enough, the waveform is a gorgeous sine wave. That is peak to peak. Well, you're looking. Sorry. Well, let's not say peak to peak yet. You're looking at about 6-7 volts. Because each one of these divisions is about 5 volts, so maybe 5.5 volts. So peak to peak by 10 volts. Pretty good at this distance. So we can move it in, and obviously it should brighten up, really bright, and our amplitude increased. So now we've got roughly 10, almost 10 volts. And that's being captured right there at the secondary coil's capacitor. So really nice, clean sine wave that's easily rectified and controlled. So not bad. When the kit's done, if I can, I'll try to stick this in here somehow. Get this out of the way. Sorry, again, one hand. The kit. The lid goes on like this. Right. Lid goes on like this, and you have like this kind of black box for the students. Now this is going to be obviously plugged in with the 12-volt power supply that I have right here. I need to change the plug. But let's take the oscilloscope off. And so imagine all this in a small board right here at a secondary that the students have wound themselves. And then as you get closer to the primary, the light lights up. So students can take measurements on this. They can do distance versus voltage. They can calculate inductance. They can calculate resonant frequency. This only works at certain frequencies. And a whole lot of things students can do. And also they can study polarization, because this coil right now is resting perpendicularly to the primary coil in there. But as I turn it parallel to that primary coil, the light lights up. So again, another great method to study polarization of these magnetic field lines. So anyway, hopefully going to get more of this stuff done.